All right, hello and welcome to AWS Made Easy episode number 49. How's it going, Rahul? How are you?
Going very well. How are things at your end?
Oh, really good. It's had a really nice weekend. We did a family barbecue. Had a good Mother's Day celebration. How about you? What did you do?
Um, Something very unique to our character over here. We actually flew to Dubai
Oh,
for
cool.
some other work, but just literally for a 12-hour period. We had one of the most amazing lunches with friends and all home cooked, amazing dishes, and then flew right back for Mother's Day celebration over here.
That's interesting how close it is. I guess it's only like 2 or 3 hour flight. And so, how was the Mother's Day celebration?
It's actually really good. We went to my parents' place and we had a nice get together. The kids, anyway, were at their grandparents while we were flying in for some urgent work. We got back and then we had an amazing breakfast at home. And yeah, it was just a nice, celebration. Special thanks to my mom, my wife, and my mother-in-law as well. I think we owe a lot to them in terms of who we are today, how we've kind of ended up in this place. So just a very special thank you
Uh,
to
I, I want to say the same thing. It's really nice to have this time to reflect on the mothers in our lives. My mom, my wife, seeing my sisters become some of them becoming very recently become moms, and so seeing them grow into that role. And kind of thinking about motherhood in general, like it's very high stakes. I think about our roles, right? We have KPIs, we get good feedback, pats on the back. They take a long time to realize the results. They have very ambiguous KPIs.
correct.
Um, very, and they don't get to do a reboot or a version 2. They have to get it as best they can the first time. So really
That's
appreciate
true.
the role that they take on, and for all mothers and mother figures, people who play that role in people's lives, it's a really important role. So glad that we had a chance to celebrate that, and I'm glad that Seattle cooperated with great weather for some nice barbecue, and it was a really nice time.
Oh, that's really cool. Yeah, I mean, this was a pretty nice weekend overall. Was a little bit of a relaxed weekend, and yeah, I really got to spend some quality time at home. So all in all, refreshed.
Fantastic. Well, we've got a
Right.
few announcements we should share before we jump into the main part of the show. Um, let me share my screen here, and we can get right into it. There we go. Here we go. We've got the non-stop savings tour. This
That's
is
right.
London, Toronto, FinOps X San Diego, and New York. So we've got details of each one of these. So depending on where you are in the world, there's still time to register. You can sign up, and we have nice receptions and all these different events planned. We're going to have lots of one-on-one time, small group time. Bro, tell us about it. What would people get out of going to our tour?
Yeah. So I think, like we've said so many times before, the focus right now for everyone is to figure out how to have an effective FinOps practice, how to save money, or how to be most efficient in the cloud, save money where there's waste, and reinvest the savings into new innovation and driving the business forward. And I think what we're trying to do at all of these events is to bring that core experience that we have, along with a lot of other customers and participants and AWS, of course, all in one place. So it's going to be an amazing experience learning from all the AWS specialists, all the large enterprises, all the small startups, all in one place. And as we discuss a lot of our learnings, our best practices, and what we have been doing at our end, and also learning from the others in the space. So I'm really looking forward to it. I have I'm pretty much traveling all of next month. So I'm really looking forward to meeting everyone there, and not just sharing, but also learning from what everyone else is working on.
Yeah, I think that's the real value of these. It's not a one way, here's all the great stuff we know, but it really is the summit where we're gathering information, we're learning, we're talking about best practices and trying to do that, get as much value out of our cloud spend as we can.
Exactly.
So we can reinvest it right back into the cloud.
I mean, at the end of the day, when you have a situation like this, the only way out of, you know, um, a downturn like this is to innovate your way through it.
Yeah.
And we are very lucky to be at a time where things like generative AI and the cloud are really driving so much of the change in the way we do things, the change in the way we experience things. If you are not innovating right now, I think the probability of surviving through this downturn is going to be very, very limited.
Yeah, it is definitely time to just be clever, think of new ways of doing things. If you're on autopilot, you want to revisit, why are we doing things this way? What can we do it a better way? Yeah, so that's we're going to take that time, get together, have these great discussions, and hopefully have some fun along the way doing it.
Exactly. And we're not only going to be there in large numbers at our booth, but we also have other experiences planned for every one of these locations. So please come by. We would love to meet with you. We'd love to discuss, your experience, your learnings, your situation, and see if we can help you. And otherwise, just learn from you.
Absolutely. So I've put the URL in the chat, so have a look at that. And then next week for episode 50, we have Arthur Petit-Pierre. He is EC2 Graviton Principal Specialist Solutions Architect. He'll be joining us. We're going to have an all things Graviton discussion, so be sure to ask questions, and we're going to talk a lot about the innovations here. Speaking of innovating your way into savings, I mean, Graviton is the quintessential, I guess, symbol of that, right? Amazon making their own silicon that's faster and cheaper and optimized for real world workloads. So we're excited to hear more about Graviton.
Exactly. So it's going to be a very, very exciting week ahead. So please leave us your questions in advance so that we know to ask your questions to Arthur, and we will try and get you all the answers. We have a ton of them ourselves, so really looking forward to this conversation.
And speaking of good conversations, if you missed last week's episode, be sure to look through the archives. That was with Meredith Holborn on cloud intelligence dashboards. That was a really, really fun episode. Still working on post-processing that one and getting the highlights, and it was really neat just learning about. I guess it was neat seeing how we were looking in the same areas, right? Things like unused resources, underutilized resources, really understanding what's driving spend in all these different categories and bringing that visibility front and center. It was really neat to see AWS's perspective on that and developed by a team of TAMs. That's really neat. That turned into basically a product in and of itself.
No, I mean, I think Meredith did an amazing job of presenting the dashboards and describing what they do. And if you are starting off with your FinOps practice and you're trying to get a basic set of tools in place, these dashboards that we spoke about last week should be the very first thing that you do. They are really easy to set up and they provide tons of value to get started. So if you do nothing else, get started with them, turn those on. You'll have tons of insights to go get some quick, easy savings right away.
Absolutely. And it's neat to see it was built with Amazon native tooling, right? That reinvestment that built with QuickSight. And
exactly.
Yeah. And also, one last thing before we jump into it, stay tuned at the end of this episode because we've got our deep dive into EC2 instance right sizing. I'm really excited to be going over that. That'll be a lot of fun. So stay tuned at the end after we go over the AWS updates of the week.
Sounds good.
So with that, should we jump into it?
Let's dive right in.
All right. Our first article is going to be on config. Let's see what's new in config. Okay, AWS Config Advanced Queries supports 62 new resource types. It's amazing they have that.
Yeah.
Well,
this is a big bulk update that's kind of come in. So AWS config really allows you to understand what's happening with your resources. And if you have a large organization, then you can actually run it centrally without having to go to every account and then run the specific service query to describe the resources. And I think that's a big deal, especially when you're doing, stuff like cost optimization queries. You want to figure out what resources are underutilized and so on. You want to do it centrally. You don't want to log into, 200 different accounts to try and do this yourself manually. And more than that, I feel like this becomes really important when you have a system that does not require you to give resource level access, and instead config can give you this data as a proxy, and therefore there is greater security. There's a much tighter control of who has access to what when it comes to these resources, and therefore this is a far better way of querying resources to understand what state that they are in.
It's interesting, like just like the cur gives you this unified way of querying your costs, it makes it so much easier to build on top of that. And config, is the analog for your configuration and understanding the state of everything with one interface. Yes, technically you could use each service has its own API and you can describe each resource, but that's a lot of boilerplate to maintain that. I guess to use AWS parlance would be an undifferentiated heavy lift. So try to avoid those.
Yep, absolutely.
So if you have AWS config, you can make much easier queries. Like I said, single query endpoint, powerful query language, and avoiding all of these service-specific describe API calls.
Yep.
And it crosses accounts and regions, so you're not doing that quadruply nested for loop to get everything that you need.
Exactly. This just simplifies things a lot more, especially when you want to glance at all of your resources as a whole across all of your accounts. So very, very welcome. I think this significantly simplifies the cost optimization practice and a FinOps practice. And I would give this a 3.5. We have a 3.5, right?
There it is.
In terms of log. Yeah.
Yes.
Great. Because it would have been good to see some advanced queries. I like that they actually listed out all of the resources. So there's a link right at the bottom of this article that takes you to the page where all the resources, so supported resource types, are all there. It would just have been good to see what kind of queries people write. What are some of the simple ones that you want to get started with? That would have been really neat to have. The other little bit that I'm a little disappointed with is the fact that they pointed to a GitHub repository and said, go figure it out right there. So that would have, just making it a little more consumable would have been helpful. But all said and done, this isn't very complicated. This is fairly straightforward. And so I would give this a 3.5.
Well, and it's neat that you can pull this in and you can use this to, I suppose this is good for making your own tooling, linters, autocomplete frameworks, all of that sort of things. So that's neat that you have all this metadata right there in easy to consume format. But it would have, in GitHub, they support READMEs at the folder level. So something called readme.resource types would have been helpful. Let's see. Is there any cost or pricing associated with this, or is that just rolled up into config's pricing?
I think it's rolled up in config's pricing.
Okay, so you don't pay per resource. It is just okay, so it's just, okay, well, that's great then. So simplifies, 3.5 stars. That sounds good to me. Well, this one seems pretty straightforward. Should we jump into Aurora?
Yeah, let's jump right in.
Okay. All right, this one is AWS announces Aurora IO optimized. Aurora IO optimized. So this is today we're announcing general availability of Aurora IO optimized, a new configuration that provides price, performance, and predictable pricing for customers with IO intensive applications.
Yeah. I mean, databases invariably are very, very I mean, just stepping back, there are two fundamental operations of a database, right? The first one is loading all your database content into memory. And the second one is scanning and, processing queries against stuff that's in memory. There are two ways to go about this. One is you give your database as much memory as you possibly can, which is kind of why you have the specialized M and the R type instances that are specifically for the Aurora databases, right? They are very highly memory optimized. You can have very large amounts of memory for a smaller number of CPUs or CPU cores that are dedicated to the database. And that's really what you want. Now, on top of that, when you have large clusters like Aurora, where you have petabyte scale content, whenever you're swapping out memory for newer pages that contain data for your queries, you want to load that up as quickly as possible into memory as needed. So having the IO optimized storage becomes really, really valuable. And I don't think this is for everyone. I think for the vast majority of Aurora users, if you just stuck with GP3 with additional IOPS, that would kind of suffice. IO optimized volumes invariably are a lot more expensive.
Like the IO2 and IO1 volumes.
Yes.
And we're not talking like a few percent more. We're talking like an order of magnitude more.
Correct. They are about 10x more expensive than your standard storage volume types. So just be a little careful about jumping right into IO optimize. That shouldn't be your first choice. See that you have ample memory. See that your queries are optimized first. And then, even then, if the way you actually operate your database requires you to constantly shard or constantly kind of swap out data from disk to memory and otherwise, then you should look at the IO volumes. But my guess is that you need to be at least many hundreds of terabytes, if not petabyte scale, to need this.
Yeah, it would have been interesting to see some real numbers. I mean, I know that everything's in percentages, but it's interesting. Okay, 40% cost savings where IO charges exceed 25% of Aurora database spend. So I would have liked to say, okay, so for example, if you have a database that's, like I said, 50 terabytes or 50 petabytes, then and how much? What does that look like in terms of real hard quantities?
Correct. And like I said, this is, to reach 25% of cost on your storage for as against what you pay for your RDS instance, that means you are already at petabyte scale. So, that's in those scenarios, it makes sense to have an IO volume to make sure that there isn't too much of a delay in loading data back into memory.
Now, interestingly, you can switch existing database clusters to IO optimized and back. Oh, interesting. Okay, so it's to IO optimized every 30 days, but switch back at any time. So I'm reminded of DynamoDB and frequent access, but that one,
right,
switch in either direction is regulated. Whereas
correct.
In this case, you can switch to IO, but you can go back at any time.
Yeah, I'm very curious to understand what the constraint might be to limiting that way. I guess you have to copy over tons of data, and that might be a limitation. You don't want to do it 10 times a day.
Well, also, I wonder how long it would take. Because if you're at petabyte scale and you say, I want to switch back to Aurora Standard, is that hours?
Let's assume volume to volume internal storage, even if you got 10 Gbps, if you did a petabyte, you'd probably run into about an hour.
No, that makes sense.
And yeah, so in those scenarios, it would make sense to limit those kind of disruptions.
It's still amazing how much data can be transferred.
Yeah.
There's that old saying: "We never underestimate the bandwidth of a station wagon full of hard drives." Well,
Latency is a constraint, not throughput.
Well, what should we give this one?
Yeah, so I think for this one, I would say simplifies. Actually, let me take that back. I'd give it a neutral. Because there's more decision making to be made about when to switch over and when not to, and by adding one more choice, it's potentially a little harder. But yeah, so it's not negatively impacting decision making, because for the vast majority, like I said, GP3 volumes should suffice. And for a few where this makes sense, they would already know to use the IO types. So not too concerned about it. And I think the article is relatively straightforward, so I'd give it a 4.
I'll bring back the article. There we go.
I like the fact that they brought in the 25% thumb rule.
Those rules of thumb are interesting. It would be nice. Let's see. Is there a? Yeah, it would be nice to have a blog post on this, just to kind of know what's powering this from a technical perspective.
Yeah.
I mean, but that doesn't. I don't think it should affect the rating anyway. It's just. I think I'm just curious.
Right. Yeah. Okay.
All right. Well, let's take a quick break. When we're going to hear about CloudFix, I'm really excited to share our CloudFix automation for EC2 instance right sizing later in the show. So we'll take a quick break to hear about CloudFix, and when we come back, we're going to be talking about Graviton 3 powered databases.
Yeah.
All right, we'll be right back.
Public cloud costs going up and your AWS bill growing without the right cost controls? CloudFix saves you 10 to 20% on your AWS bill by focusing on AWS recommended fixes that are 100% safe with zero downtime and zero degradation in performance. The best part? With your approval, CloudFix finds and implements AWS fixes to help you run more efficiently. Visit cloudfix.com for a free savings assessment.
All right, this is Aurora, MySQL, and PostgreSQL support for Graviton 3 R7G instance family. We're excited about this one.
Absolutely. I think, was it a couple of weeks ago when we talked about why the R7Gs were not yet available on the Aurora databases while they announced them for the other RDS databases. So I'm really glad that they announced the R7G for Aurora. I think this is a big deal. The migrations are what I'm most excited about, because they make it really simple to migrate over, and they do all the heavy lifting for you. So if you are on AWS Aurora, it's an absolute no-brainer to switch over to the Graviton instances. Now, the only catch here is usually the Graviton 3s are a little more expensive than the Graviton 2s, but have a significantly greater performance. So unless you're already, at the upper limit of utilization of your database, I would say hold back on moving to Graviton 3. At least move to Graviton 2 right away. But if you're already there, right size your instances, get to a point where you're already at the upper limit. And by upper limit, I mean somewhere between 70 and 80% utilization. If you're already there, then it totally makes sense to switch over to the R7G. You'd probably have significantly better performance for a potentially smaller instance type as well. So I'd say definitely evaluate it. One other possibility is that you might actually be able to switch over to an R7G, but step down on the instance size if you are somewhere in the 40 to 60% utilization range.
And it's interesting that, like you said, it's really simple. You just modify the instance type. That's just
Right.
one API call, and you just query it once in a while to see when it's completed. But that's really, really easy. You don't have to do anything
Correct.
else to make that work. And for any managed database service using Graviton, it makes complete sense. Right? This is, like I said, a no-brainer. That you shouldn't really care what architecture your database is. So why not run it on an AWS designed and optimized CPU that was designed literally for this very use case?
Exactly. But I would have really appreciated over here if they had these rules of thumb, for when you should switch over to the R7Gs, because unlike the Graviton 2s, they aren't always cheaper. So there is a higher cost associated with the R7Gs. So here is our rule of thumb that I'd love to share with all of you. If your capacity utilization is under 30% for your database, just right size your instance, cut your instance size by half, get to the right size so that you have a better utilization. The second category is if your capacity utilization is somewhere between 30 and 60%, then my recommendation would be to look at the option of switching over to an R7G if you believe that the performance improvement is going to be material enough, and then downsize by 1. So you will end up saving money, you will have better performance, and you will have better capacity utilization of your Aurora instance.
So you mean downsize by 1. So if you're in a 4XL, you go to a 2XL. If you're in a 2XL,
Correct.
go to an XL, and so on.
And I would not recommend going down below a large. So large should be kind of your base. But anything above that, like go from 24XL to a 12XL or an 8XL or so on. Those are things that you absolutely can do.
And it's interesting that your instance types are basically linear. The price is linear in the number of processors, but as you get into these bigger instances, the step sizes get bigger, right? You don't get, right? It's 8 to 12 to 16 to 32, right? There's 24. There's
24 in the middle and then 32.
But you don't get a 30 and a 31 and a 27 and right. So these steps are bigger. Whereas you can't, I suppose you could cluster a bunch of larges together, but that's not the same thing.
Correct.
So
exactly.
If you can go down by 1, especially from like a 4XL to a 2XL, that's a lot.
Exactly. So you cut down even though you pay a little higher on a per core basis for the R7G, the fact that you just reduce the size of the instance by half and increase the capacity utilization, I think that just brings tons of benefits. And then the last category is if you are already utilizing your instance somewhere above 70, 80%, and you're very highly utilized, then look to switch over to the R7G. You probably wouldn't need to add more processors for a while and still get enough ample headroom in your instance to service whatever peak workloads you're likely to see.
That's great. I think we should publish those as a short snippet, right? To really hammer that in. That's a great rule of thumb. So this is what you do under these three circumstances.
Great. We'll do that.
All right.
Okay. So in terms of simplicity, I love Graviton. It's simple. I definitely say this simplifies things. The second one on the blog post, I'd give it a 3.5 again.
Awesome. All right. Well, should we do one more and then jump into the deep dive?
Actually, there's an article that I wanted to bring up.
Oh, yeah, let's do that.
Let's bring that article up.
All right, I'll put it on screen. There it is. How Canva saves millions annually in Amazon S3 costs.
Yeah. So, one, if you haven't used Canva, try it out. It's a pretty amazing tool for helping you create content in a graphical way, whether it be presentations, whether it be your posts on social media. It helps you with a lot of very refined templates for your material, and I have loved it, and I've been following it, and I have also been an ardent fan of Guy Kawasaki, who's a chief evangelist at Canva, and his talks are amazing on how to present. So if you haven't seen those, go take a look at those. He also talks about how your presentations should be set up and the rules that drive good presentations. So check that out. It's the rules that you see at Apple, because he was a chief evangelist at Apple at one point of time before he moved to Canva. So there's tons of amazing experience and learning from his talks. Anyway, when I came across this particular article, one, kudos to the team for kind of focusing on cost savings. I mean, everyone needs to do it. I was just very, very surprised that they just didn't turn on intelligent tiering. They went ahead and created their own version of S3 intelligent tiering, sticking to the standard tier and the infrequent access tier, which you can absolutely do with intelligent tiering as well. And I don't understand why they didn't do this by just using SIT. So just a curious case of someone spending a ton of engineering effort trying to build all of this out. And it's part of their engineering blog now. I would have thought that engineering effort would have been much better spent working on features, while this was just readily available out of the box from AWS. So again, the reason why I brought this up is because I want to emphasize that point. Every organization I've known of have had some amazing engineers, right? The question is not whether they have the engineering talent to go after these cost savings and stuff. The question really is, where are these resources best deployed? Are they best deployed in doing this work that is already automated, already provided by the cloud provider, and there are a bunch of other tools that are available that allow you in a very easy manner to turn on automation to realize all these savings easily? Or is it worth having your own engineering team build some of these solutions from scratch internally? And I think my preferences fall in the first bucket, where I would much rather just use a tool out of the box that is well vetted, that is well understood, that has been out there for a while, and just use that instead of reinventing the wheel, because engineering resources are scarce. The thing that they do best is provide context for the features and the innovation that they are working on. And if I put them on something as simple as building an equivalent of a S3 intelligent tiering solution, that just makes no sense to me. So,
and the tricky thing is, for engineers, it's an interesting problem, so they're going to work on it, and you're not going to get the pushback that you want of saying, "Hey, I'd rather work on this feature." You might say,
exactly.
"Oh, cool, I'll get started." It's interesting to think about. For someone as large as Canva, they would have had an EBC, and they would have had someone from the S3 team come and talk to them and say, "What are you working on?" It's surprising that this didn't come up.
Exactly. And I think it goes back to the conversation we had with Meredith last week, where she was like, the number of instances I see where the S3 intelligent tiering is just not turned on is crazy. And so if you have a TAM as part of your enterprise support, reach out to your TAM, learn about some of these solutions that are available for you, to you from AWS, and just turn them on. They are easy, they are simple, and they are well vetted by the AWS infrastructure team. So there's really nothing to worry about. You can just turn it on and reap the benefits.
And I guess in a more general point, just don't be afraid to talk to people, right? Often, I guess as engineers, you think, okay, well, I'm going to start by coding because this is my tool of choice. But really, you want to start talking to people first and say, I'm probably not the only person to run into this problem.
Yeah.
So talk to your TAM, talk to your other contacts at AWS, talk to other colleagues at other organizations who are using AWS. Is there a way of doing this that's that's standard or has been solved already.
Yeah.
And what are you hearing? Yeah, and I think that's the more efficient way of going about it before you fire up your editor of choice and start coding.
Yeah. There are two rule of thumbs that I've applied over a period of time that I'd like to share over here. Till maybe a year or two ago, one of the practices that I used to ask my entire dev teams to do is anytime they wrote any code, I would actually ask them to tell me why and how that code that they just wrote was easy to delete. Okay. Because the one invariant in code is that it's going to change. Technology is going to change. And there's going to be some managed service somewhere down the line that's going to replace what you've written. So unless you've written code that's easy to delete, you're not going to set yourself up to leverage all of these amazing technologies that are going to come down the line. Okay. The side effect of asking this question is also the fact that when you write code that's easy to delete, you automatically imbibe all the best coding practices. I mean, take a look at object-oriented programming, right? If you truly write good object-oriented code, it's going to be super trivial to delete because of the encapsulation principles and things like that, right? So it's not just common. It's basically common sense, but also good coding practices that are baked into that one question, which is make sure that whatever code you write is super easy to delete. Over the last 1 year, the question that I've started asking is, explain to me why you really, really had to write this line of code. Imagine that every line of code cost you $1,000. Okay. Or if you want to make it even more dramatic, imagine that every line of code costs you $10,000. Are you going to make the same decision of writing all this code by yourself? And I think that kind of illustrates the state of the world that we live in, where pretty much every problem that you're working on, there's a very high likelihood that someone else has worked on it, someone else has solved it, and it is available in open source, well vetted by a number of other users that you can just use right out of the box. So the fact that you have to write new code to do something feels like just redundant effort. And again, back to focus of where you want to put your resources to work. You want to put them to work on solving the hard problems, not doing redundant work.
Interesting. I was just looking at this from a personal programming perspective. I want to put this book up on the screen. Let's see if we can do this. This is by not that one. Here, this tab. Software Design for Flexibility. How to Avoid Programming Yourself into a Corner. So he said this is, and one of the authors here is Gerald Sussman, who wrote the Structure and Interpretation of Computer Programming in Lisp. He's an MIT professor. He's got a great speech basically saying we don't know anything about programming, right? We're barely scratching the surface in terms of optimization, of evolution, of program structure. But
Right.
the idea of don't program yourself into a corner, have these seams that are easy to delete, what it says, compose, mix and match parts, small functions, standard interfaces. So like what you were saying, Rahul, make it easy to delete code, to make your code evolve and adapt, and then plus adding in open source components, not writing it yourself. Yeah, make things easy for yourself. Because anytime you write a line of code, you're committing to maintain it for the perpetuity of the project.
Exactly.
And so rather get someone else to do that.
You'd rather not just have the code at all. Right?
Yeah.
And just rely on minimal code that's just stitched together. Or that stitches together a bunch of different services that are available out there. That'd be ideal.
It's funny how it all circles back to the old Unix philosophy of simple tools chained together, simple and robust tools chained together.
Exactly.
All right. Well, we're going to take another quick break, and then we come back. We want to do the deep dive.
Absolutely.
All right. Here we go. We will be right back.
Public cloud costs going up and your AWS bill growing without the right cost controls? CloudFix saves you 10 to 20% on your AWS bill by focusing on AWS recommended fixes that are 100% safe with zero downtime and zero degradation in performance. The best part? With your approval, CloudFix finds and implements AWS fixes to help you run more efficiently. Visit cloudfix.com for a free savings assessment.
All right, I love our transition there. All right, we're going to be talking about EC2 instance right sizing. You can see I've got my special effects up per usual. I wanted to share a really neat bit about EC2. We'll get to it in a second. Let me put the article on the screen here. So here is our article. Oh, did that come up? There we go.
No. Yeah, there we go.
Cut costs in half by right-sizing AWS EC2 instances. So I'll put this article into the chat so that everyone can follow along. And okay, there we go. All right. Now let's change the screen layout here. Put us back. I'll remove this from the stream.
We've got some fancy setup over here. Switching over these visuals. I don't need to be that big. Yeah, great.
All right. So EC2 instance right sizing. And I'm trying to manage two different screens to get, because I want to make sure I can see what I'm doing and see the other article. And then I've got my stream deck that it's switching. Yeah, it's a lot. But it's pretty cool that we can do all this without a whole production crew. So I think it's a worthwhile trade-off. All right, EC2 instance right sizing. So what is EC2? This is the Elastic Compute Cloud. You rent servers by the hour. Now, I actually made this pretty cool visualization. With EC2, we started with one instance type, and then yada yada yada. 644 instance types. And I wanted to understand, what did the evolution look like to get from 1 to 64? So I made this visual using the EC2, it's instances. The website is instancecec.es website. So this is a little visualization I made. Okay, so we're starting with the 2006, and so it's just literally going through every single day, all the announcements. And so we see we started with the M1.small, and that was it for a long time. And then we get to 2010, we've got the CG1.4x large, and it's still just plodding along quite slowly, I think. But okay, so from 2006 to 2011, okay, now we're up to 12 instance types, and I've scaled this visualization based on the amount of vCPUs. And then the color is the instance family. And so as you see different colors, they're doing new instance families. And so we see this happening in 2012. We get a few more. We're up to 18 types. Now, Rahul, when do you think the big... okay, there we go. We've got a little bit of an explosion in types. When do you think the big jump happens?
I think 2015 onwards.
Okay, so there's another minute in this visualization.
Somewhere around reInvent 2015, so November 2015, and thereabouts, things just started accelerating.
So I'm gonna speed up a little bit. All right, so here we go. 2015. Oh,
see, we're already at 55. Oh wow, that is there.
Right. Here's where it really gets interesting. And all of a sudden, we're at all these different families. We've got the i3, the I series, the R series.
I think the T's also came in 2017. Wow, it is that late. It feels like we've had T's for eternity.
And the cool thing about this visualization, so I'm not an animator by any stretch. I used ChatGPT to do 99% of the programming for me on this one. I literally handed it a JSON object and just kind of guided it through this process. Okay, now we're in the explosion. So now we're at 220 instance types. Yep. So this is the evolution of the EC2 selection. Almost there. Here's our 2021. We're getting the M6Is, the G4s, the Cs. All right, and that brings us to, we just crossed 600. All right, and there's where we are today at our 638. Wow, so that is actually the JSON that I read didn't update. So we're at 644 now. So it's kind of interesting to see it in that way, and I didn't appreciate how for a really long time it stayed at one level.
Yeah.
Only in the last five years where it's really exploded in terms of the amount of instances that are there. So with
I think a large part of it is also because they created these purpose-built instances with very fine tweaks for different kinds of usages. Most of that explosion in different kinds of use cases come up in the last 5 years, whether it be for GPU-based instances, memory-intensive instances, CPU-intensive ones. Then you've got the Inferentium and the Trainiums for all the AI stuff. So, and then you had the X's that came up for the SAP and HANA kind of workload. So I think there have been so many different variants, and the explosion around them, particularly around the fact that now you have very specialized instances for very specialized kinds of use cases.
And so the interesting part is that makes right sizing a lot harder because you have so many more choices. It's not just small, medium, and large anymore. It's because we always think about right sizing in terms of an instance family, but as we see, you can actually right size from one family to another, right? If your application is more memory intensive, maybe you want to switch from a general instance to a memory instance.
Right.
So I put up this picture, and speaking of generative AI, so I was thinking about this idea of right sizing. I think, okay, the idea of right sizing has actually been in our stories for a long time. So like Cinderella is about the right size. The Lord of the Rings, the Magic Ring is about the right size. Alice in Wonderland, she's switching sizes all the time depending on what size depending on the part of the Wonderland that she was in. So I generated this Alice in Wonderland in the server room with Midjourney. So here's what we were talking about earlier. As you get to bigger instance size, the price, the jumps are bigger, right? So from a large to an extra large, it's not that much. It only seems like it's a couple of cents. But then from a 8x large to a 12x large to a 16x large, we're talking about $1 or $2 an hour difference. So we really wanted to see, can we get that right? And so we were talking about RDS for the R7Gs. Can you jump down an instance size? So we have, in order to do right sizing, we're going to use Compute Optimizer. And we've seen that the average savings are like 17%. But the important thing is that 17% is of the biggest slice of the pie, which is almost always EC2. So like some of when we're looking at VPC things, right, that's kind of at the periphery of spend often. But EC2, this is the big piece. And so 17% off, that's important. So we really want to make sure we do this right sizing. So we could do this the easy way with CloudFix. We've got this so all the automation that all the functionality that we're about to talk about in the next couple of minutes, that's all built in to the CloudFix automation. But we want to be transparent. We want to show what our process is, the AWS tools that we use, and also the rules of thumb and the thoughts that we put into our automation. So you can make your own decision in terms of which is the easiest way for you to use. But here is the process that led to CloudFix's EC2 instance right sizing finder fixer. So here's the manual way. We want to turn on Compute Optimizer. We want to turn on this thing called Enhanced Infrastructure Metrics for Compute Optimizer, and that gives us a bigger look back window. So Compute Optimizer normally uses 14 days. Enhanced Infrastructure Metrics adds a 93-day look back window. Then we're going to ask Compute Optimizer. So that's going to give us instance recommendations. And then we're going to talk about what those recommendations look like and how to decide which one to take, and then how to monitor the instances and roll back if necessary. So say if we picked one that was too small and we made it from an 8x large to a 1x large, then all of a sudden your CPU and your memory is going to go up and you want to roll that back. You don't want to do that. So here's what Compute Optimizer could look like. So say you had an M5.2x large running, and these are the specs on it, and it showed 40% CPU utilization during the day, 10% at night, 30% RAM usage on average, and less than a megabyte per second of network, less than 2 IOPS a second. So Compute Optimizer is going to give you suggestions on what you could change this to. So, for example, it's giving the suggestion that this is originally a 2x large. You could change it to an X large, to a T1.x large, or an R5.large. And so Compute Optimizer will actually tell you the monthly savings, the percent savings, and the risk. So the risk is in terms of how much headroom the new instance will give you and your kind of probability of hitting that headroom or hitting the resource limits of the smaller instance. So that's what Compute Optimizer will give you. So you want to enable Compute Optimizer. So the first command on the screen here is how to do it for one account. But what you really want to do is you want to enable it across your organizations. And so you can use that second command there, the AWS organizations, and you enable the Compute Optimizer service. And then you have to wait 24 hours. So that's what 24-hour ticker there. It'll need at least 24 hours to analyze the performance profile and start to give you some recommendations. Now, if you're using enhanced infrastructure metrics, it wants to do 90 days of data. So these are for long-running instances. These are not for ones that are only there for a few hours. These are for long-running EC2 instances that are part of your infrastructure. So here's the command to enable the enhanced infrastructure metrics. Now, there is a cost associated with them. It's quite small. So we found that worthwhile. Rahul, have you ever seen any situations where that wouldn't be worthwhile?
Not really. I think these are almost priced like lambdas in a certain sense. So no, I've generally not really come across a scenario where this becomes an issue.
Yeah, it's a really, really small cost. It's a fraction of the cost of a nano instance. So
Correct.
Definitely want to be running that. And this will give you a nice 93-day look back period for the recommendations. It makes sure it has enough data to do the show intelligently.
Yeah.
So once you've got that running, you then want to query. So the AWS API is you want to use the Compute Optimizer get EC2 instance recommendations function, and it's going to return you this JSON. So zoom in on this if you can, and it's also in the blog post. The full JSON output is in the blog post. You can kind of scroll through that. But what it's giving you is just like we saw in that table, it's giving you a list of recommendations. So for this particular instance, it says we have got that N5.2x large, and it's saying, well, this is over provisioned, so it's too big for what it needs to do. And it's saying, well, how did it make that decision? CPU was an average of 30%, and the memory maximum was 35%. So that's the output of Compute Optimizer. And then it'll give you a list of recommendations. So here's the recommendation options. You can do the M5.x large. And this is the projected, okay, if you change to that, your CPU is going to be 60% and your memory will be 70%. And that makes sense, right? It's got half the resources, so you're using them twice as much. So yeah, that makes sense. It's giving you your quantifying the opportunity that you have to save. So that's pretty cool. So when you have this list, you want to look for ones that are over provisioned. That's kind of the scope of this finder. There's other... there are also recommendations based on network throughput and that sort of thing, but right now we're looking at CPU and memory, so just changing the instance type. We want to make sure that the look back period in days is 93. So if you look over here, it actually reports the look back period. Yeah, down there. want to make sure that's 93. That's just a final check that you did turn on that enhanced infrastructure metrics, and it'll give you a performance risk. Now, less than 2.0. So they have this scale of 1 to 4, and it's very low, low, medium, or high. And so we recommend pick the biggest savings opportunity that's still in that low or very low category. But with the caveat of don't switch over to a micro or a nano. Exclude those ones. And there's actually a link in the instance recommendation specification. So have a look at that one. That's kind of shows you the different things you could get recommended. Yeah, so you want to exclude ones that are less than $100 per year, because if it's already relatively inexpensive, you don't want to, it's not worth changing anything.
Yeah.
So exclude micro or nano, exclude medium or high risk. And
the reason why we actually exclude micro and nano is for the simple reason that when it comes to the micros and the nanos, there are a lot of other parameters that start having an impact on how your machine performs. So there's a massive drop in network availability or the network throughput that's available to your instance. There's a massive drop in I/O performance on the disk that are attached to them. There's a massive drop, of course, in the CPU cores, and then also with memory. So when these many variables are changing constantly, you may actually end up in a scenario where it's more cost effective to have a slightly larger machine, because you would otherwise be blocked on I/O and blocked on network throughput. And you don't want to be in that situation. So it's just safest to avoid the micros and the nanos and stick to the small and above.
If you've ever used a Raspberry Pi, you know how easily it is to get it bogged down where it becomes non-responsive for a few seconds. That's the micro nano scale where you want to avoid that. That's just modern programs don't operate in that sizing. Remember when they used to make fun of Emacs for taking 8 megabytes of RAM?
Hey, 8 megabytes used to be a ton when you had only 8 megabytes of RAM on your entire machine. So this is back in the day when I first ran Emacs. That was, I used to only have 4 MB of RAM.
We'll compare it to an Electron application, which is, oh yeah, sure. Teams will take a gigabyte of, Slack will take another gigabyte. So yeah, I don't think a micro or a nano could run an Electron app comfortably. So avoid those. You get these little bogging down. Don't want to do that.
Correct.
So here's the instance type. You want to change the instance type. Here's a little script that just shows you how to do it, which is kind of neat. And the command line tools, you can do this AWS EC2. You can run the stop instance command, and then you can wait on that stopped instance. So to make sure it actually stopped, then you can modify the instance attribute and change the instance type. And the cool thing is your ARN will survive this. So you can retype an instance and it'll still have the same resource number. So all of your logging and things will be continuous. And then you just start the instance back up and you're good to go. Now you want to monitor your instances to make sure that, we recommend the low and the very low risk ones. But say you happen to get a surge of new traffic just when you did this right sizing exercise, or for some reason there's a bug in your automation, or you picked the wrong one and you did a high risk one and you don't have any headroom. You want to monitor your instances to make sure that look at the resource utilization. Now you can use Compute Optimizer to do that monitoring, but that's a 24-hour cycle. But you can do CloudWatch. You can set up a CloudWatch alarm on your CPU and memory, and that's real time. And we're doing a CloudWatch deep dive soon. We're going to be releasing a foundation series of blogs, and one of those is CloudWatch, because it's a foundation to a lot of the things that we do, a lot of the automation. So we'll be releasing that relatively soon, the next couple of weeks. So you can set up a CloudWatch alarm to look at CPU and memory utilization. So in this case, we named the alarm high usage alarm. It's looking at this metric called the mem used %. And so you can look up the CloudWatch metrics. There's a lot of neat metrics in there. And then this is saying, look at the average memory used over a period of 5 minutes. And if that ever crosses 98%, that's with this greater than or equal to threshold, then it can send a message to an SNS topic. And then what you want to do is, of course, you close that loop with automation, have a Lambda function that then gets that message and upsizes your instance. Now,
just an FYI, this particular API call or the command line call, it reminds me of a time where I could almost never get an AWS CLI command to work flawlessly the first time or even the third time. There'd be something wrong with some parameter somewhere as it spans into multiple pages. So I would actually use the editor to compose the command and then paste it into the command line, because that was the only way I could get it to work.
Yeah, they are. There's a lot of options associated with these, and I guess you get used to reading them and parsing the objects and how to serialize the objects onto the command line. But it's its own universe.
Correct. And this is why some of the automation really makes sense, because it reduces the propensity to actually create errors in the way you operate, and it just becomes a lot more efficient.
Yeah. And yeah, we're showing the key things, but you have to wrap everything inside of error handling and retries and logging. And
Correct.
Even for retyping your instance, right? You have to know, well, what size did the instance used to be? And so that piece of data has to be stored somewhere, because you don't get a history of instance types in the EC2 API. So you either have to store it somewhere, because say if you switched from an M family to a T family and you want to switch it back, well, the fact that it used to be an M was now lost. So you have to save that somewhere. Yeah, you have to. That means a database has to exist somewhere for you to save it somewhere. So there's always more complexity than meets the eye. So that's why the automation is really important. Yep. So we talked about this. You can use a Lambda to catch the SNS message and then upsize the instance.
Yep.
So I guess that leads into it is use CloudFix to do this. We've done this on many instances. It's saved many people a large chunk of their compute spend, which can then be reinvested and used in other ways to, like I said, we're all trying to innovate our way to a new level, innovate past current economic conditions, and do something interesting and something develop new features and new businesses. And so use CloudFix to. This is already a solved problem with the CloudFix.
Exactly.
EC2
the tool is out there. It's a solved problem. It doesn't make sense to have your engineers spend tons of time trying to figure this out from scratch.
So Canva, you can use this one. Give us a call. All right.
Awesome.
Well, this was a really, really fun live stream. Turn off the automation here. Well, thank you again, audience, for watching. Tune in next week for Arthur Petit-Pierre. We're going to be talking about the Graviton 3 and celebrating 50 episodes.
Exactly. That's a new new milestone that I'm particularly really proud of. So yeah, we are going to have a little bit of a celebration and have an amazing conversation about Gravitons. So please send us your questions. Please send us your feedback. We'd love to get this across to our guests next week and see if we can get your questions answered on the show.
All right. Well, thanks, everyone. Have a nice afternoon. Bye-bye.
Bye-bye.
Is your AWS public cloud bill growing? While most solutions focus on visibility, CloudFix saves you 10 to 20% on your AWS bill by finding and implementing AWS recommended fixes that are 100% safe. There's zero downtime and zero degradation in performance. We've helped organizations save millions of dollars across tens of thousands of AWS instances. Interested in seeing how much money you can save? Visit cloudfix.com to schedule a free assessment and see your yearly